Welcome, I'm Ian Shaw, I'm an energy manager for CBRE, a maintenance company. We're on the CEF framework for the NHS. We were invited here to give a general talk today, and when they said, what do you want to talk about? So I said, what about the drivers for reduction at the moment? Is it the carbon that counts, or is it the pound that counts? And what's the role, because I'm from an FM company, what's the role in the FM company in doing that for us? The right button. This is some of the stuff we're going to talk about. I'm not going to read it out because it's all on the slides in a minute. So it's in the news. It's in the news all the time now. COP26, climate, the war in Ukraine, it's everything. And suddenly the energy manager has become important. Everyone wants a piece of us at the moment, and I'm sure lots of you are finding that as well. And are there any conflicts between these things that are in the news? So we've got to cut carbon, but we want cheap electricity and cheap gas. So are we going to open the fracking, which will do away with the renewables? And there's all those sort of questions. So what is the driver at the moment? So back when I started, and things were in black and white and Latin and things like this, an energy manager was a nice to have. It was something that, as long as they earned the keep, we'll have an energy manager. And the Carbon Trust used to have a thing that said if you have £1 million worth of energy spend, you need an energy manager. And you need one for every million. Well, if that was the way now, there would be, we wouldn't all fit in this room, would we? So things have moved on. Projects and efficiency was driven by return on investment. So how quickly does it pay for itself? Well, we're not bothering. And then there was arbitrary things like, if it pays for itself in 2 years, we'll do it. If not, we want a bit more of a business case, and then we won't do it. And targets were arbitrary, or so it seemed. Lots of things, 20% by 2020 was one of the big ones, and where did that come from, and did everybody make it, and all those sort of things. It kind of got dropped a bit, and there was Kyoto in the background, and all those sort of things. So, and often the energy got lumped in with QHSE. It was, we need an energy manager, we're not quite sure how. We've got a health and safety guy who we're not quite sure what they do either. So we'll lump them in together, and they can help turn off lights and help with the F-gas and the Legionella and things, because that's energy-ish. And then saving the planet became cool, just before COVID hit. So we had the COP21 in Paris, climate crisis, lots of councils and everybody declaring climate crisis. We've got, it's got to be done. Greta Thunberg coming across and arguing with the world great and good, or the great. Anyway, arguing with people. Get science-based targets, net zero, corporate responsibility, it all came in, and carbon came to the fore. Everybody had carbon targets. We've got to cut, we've got to be net zero, carbon neutral by 2030. Again, lots of arbitrary targets. And the energy manager was in demand. And we were really on the up and up. We couldn't get enough people. And then it all went wrong. The world went wrong. It went to, COVID hit, and everybody went home. And we all sat at home twiddling our thumbs saying, what's going to happen? The world shut down. And then when we did come out of COVID, we came out very, very quickly, a lot quicker than the world expected. And the energy industry wasn't ready, so there was a shortage. There were some regimes, countries in the world saw it as an excuse to up the prices, to buoy up their economy, get in a few rubles, and it drove the price. And then other things happened. There were shortages because we came out too quickly, the world wasn't ready for it. And then the war in Ukraine, and the prices had gone silly, and price became the driver. So the energy manager was even more important. So when it was a 2-year ROI, became a 1-year ROI. And just on this graph, this is the latest wholesale price for the UK as of Monday. And the horizontal yellow and blue lines are the price caps for the wholesale price. So it's funny, and I don't know whether this is right or not, but the current wholesale price is just under the price cap. Because it's market driven. I think there's a whole pile of people in Canary Wharf trading the markets on this thing, and there isn't really a shortage. But that's where it is. So the price caps kick in, but it's still higher. We're still talking 20 pence for unit of electricity, 7 pence for a unit of gas, which 4 years ago was just not dreamed of. So is it pounds or is it carbon? Decarbonisation is the big buzzword. Electrification will probably increase costs. If we take a gas boiler out at 90% efficient, put an air source heat pump in at 360% efficient, yeah, the kilowatts will go down, the carbon will go down, but the cost will go up because there's still that differentiator between the pounds for gas and the pounds for carbon. Electricity is more expensive. Electricity is more efficient, especially heat pumps. But gas is currently cleaner than grid electricity. And I've got another bit about green electricity in a minute, and it's yeah, we have some arguments later if people want about green electricity. So are the targets drivers mutually exclusive? Can we cut carbon and cost at the same time? We can cut the carbon, but the cost may go up to the electricity prices. So are they mutually exclusive? I don't think so. I think it's all in the timing. So we need to go back to basics. The kilowatt hours. The kilowatt hours is what drives the carbon. The kilowatt hours is what drives the price. If we can cut the carbon, if we can cut the kilowatt hours, we cut the carbon. And we cut the price. The big bit is the timing of when we do that. Yep. We should be cutting the kilowatt hours now on our gas plant and our oil plant, because that is the carbon driver at the moment. That is the dirtiest thing. While grid electricity is dirtier than gas, and while gas is cheaper, we should be using gas. Why the rush to electrify now? Electricity is dirtier than gas, and gas is cheaper. But we're seeing lots of people come in saying, take out my boilers, put in some heat pumps, put in some resistive heaters for my hot water. Now's not the time. There is a climate crisis, but there is a pounds crisis even more at the moment. I spoke to an NHS trust a few weeks ago, I won't name them. They pay £140,000 a year premium for green electricity. When I said that's 2 nurses, it was oh, I hadn't thought of it like that. So for a certificate, you're sacrificing 2 nurses. Or spend that £140,000 on energy efficiency, reduce your kilowatt hours, and again next year and again next year. Then in 2030, when your target's hit, buy the teaspoon worth of green electricity. But don't buy it now. They're making it anyway, whether you buy it or not. And with location and market-based reporting, you've got to report the market anyway, so why take the hit on the... That doesn't always go down well with chief execs, because they like to be presenting their green credentials. So until 2024, 2025-ish is when the electric grid is predicted to be cleaner than gas. It was predicted to be cleaner than gas, but with the stuff that's going on now, possibly opening the fracking up, which won't come online for another 18 months anyway, and probably using more coal this winter, the chances of the grid being cleaner than the gas anytime soon is not there. So, where do the FM teams sit into this? Most of the primary energy used in the hospitals is looked after by the FM teams. And when I mean the FM teams, I mean the guy with the spanner, the guy with the overalls, the guy with the toolbox, the engineers, the technicians that run the plant, the guys that are walking up and down the corridors, fixing the lights, fixing the heaters, in the back rooms, fixing the boilers and the chillers and the CHPs. They're fundamental to the operation. We can have lots of consultants, we can have lots of people coming up with big plans, and we can change the chillers to super duper high efficiency free cooling heat recovery chillers, but if the fitter doesn't know how to run it, it's no point. They've got to be, those guys on the ground are the ones that control it. Everything they do affects energy consumption. The good maintenance equals good energy efficiency. I think if you're going to a garage, buying a new car, and the book says you'll do 60 miles per gallon combined urban driving at whatever 54 miles per gallon, and then you drive it at 70 miles an hour in third gear with the choke out up the motorway, you're not going to get 60 miles per gallon. So you've got to drive the buildings and you've got to service them how they're designed and serviced to be built, or built to be serviced. Control. is the main thing. One of the first bits that ever gets cut out of a maintenance contract is the visit by the BMS engineer. Comes once a week. Yeah, we don't need that. It's only once a month. We can cut some cost out of there. In the meantime, the control starts to drift off. Just because we're making set point, just because the phone doesn't ring and say it's too hot and too cold, doesn't mean it's doing it efficiently. The heating and cooling cores can both be open. The set point on the air handler may be to deliver the air at 18 degrees C. So in the summer it cools to 18 degrees C, and on the other end all the fan core units are heating. And we've got no link between the two. The FM guys and the BMS guys are the ones that control that. So why do they fail? Why do the FM companies fail? Plant gets put into manual override. Some people call it hand, because we hand off auto. I like to think of it as manual override. It's more in your face. It's wrong. Hand is just, it's in hand. Manual override is a manual override. Set point changes in response to phone calls. We're too cold. So the engineer will turn up the set point. Well, if it was meeting 22 yesterday, and it's not today, changing the set point isn't the problem. There's something else has gone wrong. There's a filter blocked. There's a pump not running. There's a belt slipping. If it's not reaching 22, turning up to 23, it's not reached 23 either, is it? So it's getting them to do the right reaction to the right thing. Fiddly fingers and no control over changes. People sat again, oh, I'll just have a look at the BMS and that looks a bit high, I'll change that, I'll move that, I'll change this. And no control over it and no perception of what happens downstream. What is the consequences of changing that set point and doing those things? Time clocks change temporarily. We need the heating on, there's a conference, can we have the conference suite on tonight, and it never gets put back again. Projects not commissioned properly is a big one. We're going to have this super duper free cooling chiller with heat recovery and everything, and by the time it's put in, the guy that the project sponsors moved on, no one quite knows how it works. The engineer gets to go, so I've really no idea. So they either bypass it or put it into manual override. Because when they switch it on, the boilers drop out and there's never any fix between the two. There's a lack of investment in CapEx and OpEx. The picture there with the two, one fan, two motors. So the duty motor drives the fan and the belts are connected to the other motor. So it drives the other one as an alternator, and then the following week it works back the other way. That should be changed. That's not a critical thing. It's still going to fail. It's not critical. My thoughts are you can join the two together with a wire and give it a spin, but apparently that doesn't work. We should be changing those sort of things, but we haven't got the money this year, we haven't got the capital this year. Lack of knowledge and information, so how do the things work? And the lack of empowerment is the big one. The engineers don't know what they're allowed to touch. They're generally told don't touch things, leave it as it is. And it goes not just the engineers, but cleaners, security guards. They're told if the lights are on when you go in the room, leave them on when you leave, even if there's nobody there. They should be empowered to turn things off, turn things down. There are some caveats on that critical stuff should be left critical. But things get seen as being normal. The top right-hand picture, there was some plant in a plant room. I was walking around with the boiler engineer, plant engineer, and so these pumps, there's about 30 kilowatts of pumps left in hand, the duty and standby in hand, all of them. And there's primary pumps, CT, VT, all in hand. Why? Because, it's supposed to be like that. Well, why is it supposed to be like this? Well, there's a label, says it's got to be like that. You're not questioning this? No, the label says it's 3 years. You can't see, but there's a date on the bottom. I found it 3 years, almost to the month after they were switched into hand. I've covered up the phone number so I phoned the person and said, that's still like that? Yeah. He said, well, what it was, on a Monday morning, the duty pump stopped and the standby pump came on. In the meantime, the boiler locked out on no flow. He said, all it takes is the change to bring the standby pump on and then turn the duty pump off. 3 years. 30 kilowatts of pumps running 24 hours a day, 7 days a week. Just pumping heat around the building. But the engineer thought it's supposed to be like that because there's a label on it. So, and the filter at the bottom. Bad maintenance. Couldn't get heat out of an air handling unit. So the engineers have been turning up the set point. still couldn't do it, so they turned up the flow rate from the pump, still couldn't get the heat out. When we eventually got there, that was the state of the filter. The PPMs said the filter had been changed and had been signed off, or the filter had been checked, the strain had been checked. I'm not saying the guy didn't do it, but that doesn't look done to me. But it could have been something stirred up further around the system that caused that. So the big question is, don't take things at face value. If you can't get the heat out of it, then there's a reason we're not getting the heat out of it. Turning up the set point doesn't sort it. So what do we need to do about it? Energy training for all. Everybody should be an energy champion. We have the health and safety champions. Everyone's a health and safety champion. Don't walk on by and all that sort of thing. So energy training for everybody in the organisation. And tell them what they can do, what they can't do, what the implications of doing or not doing are. So that's don't walk on by. Question, why is it like that? We had a heating system that the guy said, we've got to leave it on because when we turn it down, it leaks because the joints, and it was designed like that. And we said, it wasn't designed like that. They didn't fill it with cold water, it leaked, and when they turned it on and heated up, it stopped leaking. They filled it with cold water and it didn't leak. It's bad maintenance has caused that. But over the years, they convinced themselves that was right. I've got to put this one in. It's the employ reputable companies with good technical energy support. If we just have the friend of a friend's mum's guy with a van, he will do what he's always done, or she will do what she's always done, and get it working, and very well, but not necessarily improving and making things better at what we're doing. Don't accept projects that are complete or operating as designed. And we often do that because there's pressure, we've got to spend the money. If we don't finish this project by today, we lose the money, we've got to get it out there. Empower the FMs to do things without resorting to a higher authority. An example of this is radiators in a corridor. The radiator valves are all set on 6, because the radiator is either 6 or a snowflake, isn't it? There's everything in between. So we said, why don't we change them all to lock out at 3? Can you do a business case? And what's the savings going to be? So, well, we sort of scratched our heads, did something, and then it has to go to the Energy Committee, which meets every 4 weeks. And then they'll come back with more questions, and then more questions, and it never gets, by then it's summer and no one does it. So things that you know are going to do it, just do it. Yeah. Regular inspections and walk rounds by other people. Swap engineers for a day with a different site within the trust and say, you have a walk round and pick up energy stuff on their site and they'll come and do yours. And that sort of concentrates the mind a bit on doing that. And robust reporting with feedback. The guys need to know if they've reported something, that something's been done about it and what's happening. And same with meter readings. There's so many sites where the guys read the meters. What do you do with the meter readings? They go in the book on the shelf. And, no, they go in the book on the shelf. So why are you doing it then? Because it says we've got to do it, and they go in the... Pointless. If they're not getting the feedback, then it's not working. The FMs are fundamental to meeting those targets. And that's it, ahead of time. Questions, 15 minutes of questions. Because you all want to go home. It's the last day and everyone wants to go home, and I got the death slot. Thank you very much for listening then. Thank you, and have a great trip home.